This is the fourth in a series of videos in which I'm building a power supply based on the RD6006 switching controller. If you've watched the previous videos, then you know that I built one of those power supplies using an off-the-shelf Chinese switch mode supply, and it generated a lot of noise, mostly from the Chinese supply that I was using, not from the RD6006 itself. Now, in the title of this series I'm indicating or implying that I'm building a linear supply. Now, of course, the RD6006 is not a linear supply, it's a switching supply. What I'm talking about here is a linear back end primary supply. The RD6006 will of course still be a switching supply. However, taking this approach will remove the horrendous amount of noise that I was getting from the switching supply that I used in the first units I built. If you're not sure what I mean, you can go back and look at the first series of videos in which I built the first supply. I'm not trying to imply here that the final build will be a true linear supply. What I'm doing is getting rid of the bulk of the noise that's created, and the reason for doing that is to have a supply that generates the minimal noise, albeit it's still a switching supply. Also, in light of some of the comments I've had, yes, you could buy an off-the-shelf transformer to do this, but where's the fun in that? The purpose of my channel is to try and show different ways of doing things, and some fundamental in electrical and electronic engineering. And so the purpose of this series of videos really is to show how you could go about rolling your own transformer and building your own back-end power supply from scratch. If you prefer, you can just of course buy an off-the-shelf toroidal transformer, bolt that into the case, but I thought that would be fairly dull, so I thought it would be more informative to show how I go about winding these. Again, this is not the only way you could do this. You could take any approach that you like. Also, in a previous video I said I'm not going to reuse the wire. I also said that you can reuse the wire if you want to, and I in fact used to recycle wire and reuse it myself. However, I don't do that anymore. It's very time consuming to unwind the transformer, and although you can straighten copper wire fairly easily, once it's been bent, it's work hardened, and it doesn't matter if you then straighten it, you still won't get a very neat winding, simply because it will try to resist bending in the place it was bent originally, and you'll find that you get weird kinks and twists, and the finished result won't be very good. In all honesty, it doesn't really matter, it still work. The only real danger is if you damage the insulation. It's obviously very thin insulation on these, and if the insulation is damaged you can get shorted turns, and obviously that can cause you some major headaches. But if you want to save some money, then by all means go ahead and recycle the wire. Okay, so what I've got here are the two reels I'll be using. So I've got the thicker wire, which of course is for the secondary. This is quite thick wire, and the secondary is the first winding we're going to put onto the transformer. And then we've got the primary. I've had to go for thicker wire than on the original transformer because I'm changing from a 240 volt primary winding to 120, and so I need to of course raise the current handling capability of the primary winding because the VA is still the same. Incidentally, when you're looking at the rating for transformers, these cores are rated at a realistic 225 VA. Now, VA and watts are not the same thing. I'm sure you already know this, but just bear that in mind. If you get a 400 VA transformer, it almost certainly will not provide a constant 360 watts unless you manage to get a very good power factor. In general, the current and voltage of the mains you feed into this will be out of phase. You've got quite a highly inductive load here. You've got a lot of capacitance on the output of the transformer, and that does tend to impact on the power factor quite severely. And just a rough ballpark calculation, you need a power factor well above 0.95 in order for a 400 VA transformer to actually give you the 360 watts you're looking for. Because don't forget, you will have losses in the system as well, so you're not going to get the entire 400 VA in effect pass through the system. You will lose a fair amount of that, so you do need something a bit higher. So what I have with a pair of these transformers is a realistic 450 VA. It's probably a little bit more than that. These cores are a little bit over 425, but at least I will get a nice bit of overhead, and I should be able to achieve the full 360 watts continuous output. So the next step, of course, is to rewind the transformer. In the last videos we got as far as stripping the original transformer down, and we ended up with just a bare core. So what I've done now is I've taken the core that I stripped down in the previous videos, and I've wound 1/3 of the number of turns required onto it using thinner wire. There are many ways you could go about winding this, and with such a short winding, because there are only 60 turns on this winding, but they are very thick wire, and if I was to try and put wire this thick onto a smaller spool so that I could pass it through the core, I would end up bending the wire, and that would make it very difficult to get a neat winding. It would still work. You can take that approach if you want. It's just I like to make the windings as neat and tidy as I can, and if I try spooling this onto a smaller reel, it would end up with a messy winding. So what I need to do is figure out what length of wire I want to cut for the winding, and the reason for that is the technique I'll be using with this thick wire is to cut a single piece of wire, pass it through the core so it's approximately halfway through, secure it with tape, and then I'll wind in one direction until I get to the end of the wire, and then I'll secure that end. I'll then come back and wind from the center point again in the other direction until I've got the right number of turns on the core, secure the end, and then just trim off the excess wire. That's an easy way of doing it. I'll hold this in a vise on the bench. Unfortunately I can't show this on camera because the tripod would get in the way and I'd end up wrapping the wire around the camera. But I'll show it once it's completed. But what I'll do now is take this wire off. As I say, I've put 1/3 of the number of turns on that are required. So there are 20 turns on here now of a thinner wire. And that's for two reasons. One, so I know what length of wire I'm going to need. I'll just use a piece that's 3 times this length. But also so I can determine the spacing of the turns on the transformer. If you prefer, you can mark these off using a pencil or something on the core and get a nice neat winding. Doesn't need to be particularly neat. I just like to make them as neat as I can. And once I've got this winding on the core, I'll get back on camera, we'll have a look at it, and we'll go from there. Okay, it's been about 20 minutes. I've got about 40 of the turns on, and just to try and show you the technique, I can't show you much of the winding because, as I said, the tripod and camera will get in the way, but I'll try and do one turn and show you the method I use. It varies depending on the thickness of the wire. If you could use multi-strands of a thinner wire, so you could, for example, wind 2 thinner wires in parallel at the same time. But I tend to use thicker wire when I can. It's quite easy on big transformers like this. But you do need plenty of space. So what I've done is have a single strand of wire, and I pull it across the workshop, pass it through the core, pull it through, and then just bend it around so it's neatly formed. So I'll just give you an example. So I pass the wire through the core, so the camera's actually in the way here, so I'll try not to knock it too much, and pull the wire through. And the main thing is to try and avoid the wire forming twists, otherwise you'll have a job keeping the windings properly separated on the core. And I pull it through. When you get it almost all the way through, you need to put a bend in it. It won't, the wire this thick won't form on its own, and then the same underneath, and then the same on the back, and then on the top. And to keep the windings properly spaced, a piece of transformer tape. Okay, and then you're ready to do the next one. So I can't do it with the tripod in the way because I now need to pull the wire across this side of the transformer. I can't because the tripod's kind of sitting down here. Okay, but that's the method, and you just do that for all the turns, and it's as easy as that. So I'll get this finished off, should take about another 10 minutes, and then I'll get back on camera and we'll look at the result. Okay, so that took about 35-40 minutes. I've now got all 60 turns on the core. They're just loose on here at the moment. What I'll do now is just even them up to make it a bit neater. Then I'll tape them up and I'll put on a thick layer of insulation between this winding, this is the secondary, and then I can wind the primary on top, and that will be this transformer done. So in the next video we'll look at winding the primary. That's 300 turns, but is a much thinner wire, so it'll be far easier to do that, and then we'll be able to test it and see if we're getting the correct voltage.